Welcome to Python Probability Distributions with SciPy. In this lesson, you will use Python to explore random events and probability distributions using the SciPy library. You will see real data, make plots, and run simple simulations. Let us get started. Running the cell now. Now you will load the basic Python tools you need for math, data, charts, and probability. This line hides any warning messages, so things stay clean. NumPy helps with math and arrays. Pandas works with tables of data. Matplotlib shows nice charts so you can see your results. SciPy is your toolbox for probability, including many distributions. Running the cell now. What are probability distributions? Probability distributions let us model random events, like rolling dice or measuring heights. With distributions, you can describe the chance of different outcomes. SciPy makes it easy to use many probability distributions in Python. Running the cell now. Let us try something simple, rolling a dice 10 times. This line creates 10 random numbers, each a possible dice face from 1 to 6. Here you see your 10 simulated dice rolls. Running the cell now. Let us load a real dataset, shampoo sales over time, from a CSV file online. The URL points to the data. Pandas reads the CSV into a table. Now, see how many rows and columns the table has. Next, see the first 5 rows of the table, so you know what is inside. Running the cell now. It is time to see the sales pattern with your own eyes. The big figure size makes the chart easy to see. Here, you plot the sales for each month, connecting the dots. The title helps you know what you are looking at. The horizontal axis shows which month you are in. The vertical axis shows the sales numbers. Finally, show the chart. Running the cell now. Try thinking about how random events could affect these sales in real life. What is a normal distribution? A normal distribution is a classic bell curve shape. It describes many things you measure in the world, like heights or test scores. Let us draw one in Python. Running the cell now. Here you build a bell curve, also known as a normal distribution. First you make values from -4 to +4 for the chart. Then you calculate how likely each value is in a normal distribution, with average 0 and standard deviation 1. You plot these probabilities as a line, and give it a name. A title makes your chart easy to read. The bottom axis shows possible values. The side axis shows how likely those values are. The legend labels your line. Here comes your bell curve. Running the cell now. Now, let us see an example, simulating heights of 1,000 people. This keeps the random numbers the same each time for teaching. Here you create 1,000 random heights with an average of 170 centimeters and a spread of 10. This shows a histogram that counts how many people have each height. Add a title so you know what you are seeing. The bottom axis is height in centimeters. The side axis counts how many people had that height. Now you see your simulated sample. Running the cell now. Suppose you want to know the chance that someone is shorter than 180 centimeters. Set your average height. Set your standard deviation, which means spread. This line finds the probability using the normal curve. Here is the answer, written out, nicely rounded. Running the cell now. The binomial distribution. Binomial distributions model how often something happens out of a number of tries, like flipping a coin 10 times. Let us see how likely it is to get certain results with 10 coin flips. Running the cell now. Here, you model flipping a coin 10 times. 10 flips gives you a set number of trials. Each flip has an even chance for heads. You look at all possible numbers of heads, from 0 to 10. This finds the chance for each possible outcome. You build a bar chart showing how likely each total number of heads is. A clear title explains the situation. The bottom numbers show how many times you got heads. The bars show the chance for each count. Here is your chart. Running the cell now. Now, find the chance of getting exactly 5 heads in 10 flips. This computes the probability directly. Here is the result, rounded for readability. Running the cell now. Now let us involve you. Imagine you pick a random number between 1 and 6. When you run this code, type any number from 1 to 6. You will see your pick printed back to you. Running the cell now. Try practicing input above and talk about why humans are not really random. Practice prompt. Can you think of a real-life example where knowing probabilities could help make a decision? Share your ideas or write them in your notebook. Running the cell now. Suppose you want to model rare sales events, like big orders. First you calculate the average sales per month. Then you use the Poisson distribution to make up 12 sample monthly counts, using that average. This shows the results as a bar chart, 1 bar per month. You add a title so others know what it shows. The bottom labels are months. The bars are simulated monthly sales counts. Now, see your simulated rare events. Running the cell now. Now it is time for a mini-project. Suppose you want to know how confident you are about the real average of all possible sales. You use a method called Bootstrap. You randomly pick samples from your sales, with repeats, take their means, and do this many times. You take the range between the lowest and highest 2.5% to build a confidence interval. Here you print out that 95% confidence interval, rounded. Running the cell now. For best results, always check for missing values or mixed-up data types before working on probability questions. This prints how many missing values are found in each column. This prints what kind of data each column has. Running the cell now. Sometimes your data is stored as text, not numbers. This line tries to turn sales into real numbers. If Python finds a problem, the code will print an error message without crashing your notebook. Running the cell now. You can compare 2 different sets, such as the heights of men and women, or 2 age groups. Here you make 2 groups with different averages and spreads. This is the second group's simulated values. Plot both groups in one histogram and make each group see-through. Add the second group to the same chart. Show the legend so you know which is which. A title tells you what you are seeing. Label the bottom axis as height. Label the side as number of people. Now you can see the differences side by side. Running the cell now. Challenge exercise. Change the code above to see how the shape of the distribution changes for different values of average, which is mean, and spread, which is standard deviation. Try different situations and see what happens. Running the cell now. Practice makes perfect. Try 5 times. Lesson recap. In this notebook, you learn to use probability distributions in Python with SciPy. Simulate and plot random events. Analyze real-world data with probability models. Practice coding with real datasets and exercises. Keep experimenting and trying new questions. Running the cell now. Thanks for learning. If you enjoyed this lesson, please like and subscribe on YouTube. Stay curious and keep exploring Python. Running the cell now. Do you have questions or ideas for new lessons? leave a comment on the video.